Hello, friends. Welcome to this new series. This is called Differential Equation for Engineers. In this series, I will talk about um, differential equations, of course, and the way I designed this series. That in this series, I will upload on a regular basis 10-minute long lectures, not super lengthy or not super short. 10-minute lectures on differential equations, on different techniques and problem solving. And this and just I just also want to highlight that this lecture will be focused on more or less application. So I want you to learn differential equation also, but also want to keep in mind what the application can be. So if you're an engineer or like an engineering student right now going through like engineering courses, and if you wonder like if you're taking a ODE or PDE course that is mandated by your program, and then if you wonder like why am I learning all this math. And so sometimes, and I know it happens a lot to the students that they go through a course, but they don't really understand why they're going through that course, why they're learning it, right? Because sometimes our teachers, they don't do a great job communicating that message. So what I want to do in this course, like we'll talk about differential equations, we'll learn about differential equations, we'll discuss different aspect, different problem solving method of differential equations, but also we will focus mainly on the application. And this course will be moderately paced, so I do not expect you to get everything in the first place. And this is if you are right now taking a class that involves you to do homework and regular basis sit through exams. This is not the course for you, because in this course I do not want to teach a differential equation, or I don't like to use the word teach. What we're going to do, we are going to discuss differential equations. And I just don't want you to rely on these YouTube lectures for you to pass the course that you are currently taking. So if you're currently taking a differential equation ODE or PDE class in university, I would advise you to follow your lectures that is given to you by your teachers, professors. Focus on those, because whether you actually learn differential equation or not, you need to get a good grade in your exam. So if you want to get a good grade in your exam, this course is not the perfect course for you, because here we'll go at a very slow speed, a moderately paced speed, and we'll just discuss differential equations. So who will be benefited from this course? Of course, like any engineering student or any science background or anybody else. I don't want to limit the scope of this course just to engineering or science, because anybody from different fine arts background also can take this course, because sometimes they need to analyze some of the data that they uh, collect in their surveys, whatnot. So sometimes having this background of differential equation can help them analyze their data. So this can be useful for anybody who is a student of mathematics, I must say, or at least applied mathematics, whatnot. But if you wanna, so this course is for you if you studied differential equation in college but you haven't understood anything. So if you're that person, this course is right for you. Or if you are just curious, if you just want to know or like refresh your knowledge, in that case this course will be right for you. And like I said, I'll be very slow. I'll be going at a very slow speed. I'll not rush the course, and it may take a while to finish the all the topics that I intend to finish. But like I said, this will be a slow or like moderately paced course. So yes, if you are right now taking a class that involves understanding or learning differential equation, rely on other sources, rely on your class notes. But this course or this series won't help you get there, because usually a semester runs quite fast, and I'll take a while to finish this course. Um, this is also, like I said, this will be an useful course for test takers who want to take, like if something like, let me, PE, FEP, this kind of course. And some of these courses, some of these not course, I want to mention certification, they involve understanding or solving problems in differential equations. So in that case, if you're that person, maybe this course will help you. And then by the time I upload all the episodes on this topic, I don't know how many episodes it will take, like maybe 30, 40, even more. I imagine it would be more than that. And this, like I said, if you are just casually learning differential equations as a student or as a test taker, of course I think there will be a lot of benefit from this course. And also, if you want to keep your brain active through problem solving, I would encourage you to just casually watch my courses, my classes, just to keep your brain active. A lot of students, they want to learn the foundation of AI and machine learning. And differential equations are basically one of the mathematical foundation of AI machine learning. So I'm not going to teach you anything related to AI or machine learning. I just want to tell you that if you learn differential equations towards the end, it will help you understand AI ML algorithms more. That's a promise, but I am not going to teach you anything about AI or ML in this course. This is just I just want to let you know, this is just to motivate you, why you want to understand differential equation more than what you studied in college. Just a little background about myself. My name is Dr. Abdullah Saad, and I am currently working as a materials engineer in an American based company. And I have background in mechanical engineering and also materials engineering. And yeah, I'm a lifelong learner, and I'm very much as enthusiastic about differential equations and also all other mathematical aspects that we use in engineering. And I just want to get on this journey with you. So let's get started. So first of all, what I will do, first of all, I will just again start with a common question. What is a differential equation? If I ask you to define a differential equation, how would you define it? So usually, if you are already if you already have taken a class on differential equation, you would know, like, yeah, this something like this, would be classified as a differential equation. Let's just write something like this. Right, so you would call this as a differential equation. So what do you have in a differential equation? So we do have something like x, y, some constants and some operators and some function. So basically we have some variables, right? So we have some variables. So like I said, like we have variable x, variable y, and so here within these variables, x is independent variable, right? And y is dependent variable. Usually that's how it goes, right? So any equation that involves an independent variable, a dependent variable, and a derivative of that independent variable, right? That will be called. So, like I said, an equation that involves these three things, and for example, okay, let me wipe it. All right, let's do this again. So, an equation that involves these three things. Let me change the color. Okay, x, y, dy by dx. In different form, it can be like this: dy by dx, right? So, and like just not just x, it could be f of x, it could be f of y, right? It could be an implicit function like fxy. So anything like an of x or a function of x, uh, y or function of y, and a derivative of y. Okay, so an equation that involves basically all these, you can call them as a differential equation. That's it. All right. So they can come in many form. They can come in many form, and we'll talk about them in coming lectures. For example, our very, so if you just passed high school, maybe you know that this comes from Newton's second law, right? Newton's second law. So this is a differential equation. We often do not appreciate the fact or like think about that way, but this is basically a differential equation, and because this can be written like this: F, which is force, mass, which is m is which is mass, and x, a can be written d dt. Okay, and depending on if f is force is a constant, or like it could be, if it is an oscillating force, then it could be minus kx. Okay, so for example, if f is a function of x, in that case you can call this whole thing, this is the differential equation, right? And there are ways to solve it. Just to keep it simple, so anything, like I said, that involves a dependent variable, independent variable, a dependent variable, and the derivative of such variables are called differential equation. Now, what is a common form of a differential equation? Let's go to next page. Okay, let me insert a new page. Okay, we change the color. So the common form of a differential equation is f x y dy dx dxn. Now this equation is called ordinary differential equation. So you get the point. ODE. Right? So this is called ODE, or ordinary differential equation. Now I just want to highlight this. We often use these terms ODE, PDE. So let me go back, and then let's talk about some of the common jargons related to DE, right? DE. So like we just talked about ODE, which is ordinary differential equation, ordinary, right? And the first part of this course I will dedicate to ordinary differential equations. Now, there are another type of differential equations which we call PDE, which is partial differential equation. Okay, in partial differential equation you involve partial derivative. So in ordinary differential equation you involve like a regular derivative like this, but in a partial differential equation you involve like a partial derivative, right? So if you know enough calculus, you know how to solve a partial derivative. And we'll involve them in a partial differential equation, and we'll talk about them in the later part of this class. Now, when it comes to differential equation, there are some other jargons that we need to know, and one of the jargons is the order of a differential equation. So this is this is determined by the highest derivative appearing in the differential equation. We'll talk about them later. And another topic is linearity, linear versus non-linear. Okay. Then other some other common jargon is homogeneous versus non-homogeneous. Okay. Now, these, why do we need to know them? Because these terms will be useful to identify a type of differential equation. Because differential equation, yes, we just discussed there could be two types of differential equation, first ODE and PDE, but within ordinary differential equations there could be many different types, and that will depend on their order, the linearity, their homogeneity. Okay. So for example, here, let's just say this equation. Let me write down our equation here. I can change the color, I guess. Okay, so dy dx square plus omega y to sine x. Okay, here omega is a constant. Let's just, okay. Now, so we just learned about some of the jargons, and so we'll talk about one thing, which is order. So order of an equation is the order of the highest derivative. Okay. So here in this equation, see, I just changed the color anyway. In this equation, you see here, this is the highest derivative, and it has a second order, right? Second order derivative. So this equation would be called second order ODE. Okay, second order ODE. Now here's the thing. This equation could be linear or non-linear. Now this would be identified as a linear equation because it doesn't have any non-linear term. But if the same equation, if it had a non-linear term, let's just say this same equation, like I'll just change the color, maybe I'll write in a red. So here, dy dx, this equation is still linear. Okay, this is still linear, but how do I make it non-linear? I introduce non-linearity. So this is a non-linear term, so that makes it a non-linear ODE. Okay. Now, yes, this is a non-linear ODE, but what is the order? You see, the highest derivative has let me change the color, maybe 1, right? So this is a first order. Okay. All right, so let's do some other example. For example, x cube p cube y dx cube plus 5x dy dx plus 6y. Okay, it's a long equation, but okay. But here's the thing. So what's the highest derivative here? Let me change the color. The highest derivative is this one, then this one. So highest derivative is this one, so order is 3. Okay, but there is no non-linearity here, so it is a linear equation, so we can call it third order linear equation. Okay, now let's look at another example. Okay, here what is the order? First let's talk about what is the order. The order is, you guessed it right, order is 2, because that's the highest. Okay, highest order. Now question is if this is a linear or non-linear. So I mean it is, sometimes people can miss it, but here you can see here y is multiplied with dy by dx, so this is a non-linear term, and because of this term this is a non-linear ODE. Okay, all right. Now so that brings, so usually so we'll start our course by solving basically linear ordinary differential equations. Okay, so linear ordinary differential equations, how do they look like? What's their general form? Linear ordinary, why am I writing the whole thing? I can just write ODE, linear ODE, right? Let's just say linear ODE. So the generic form from the linear ODE, let's take a note. So these are the functions, and you expect you have different order of -1 x dn -1 y dx n -1. Okay, dot dot, and all the way 1x dy dx plus a0 x y to f of x. Now depending on the value of the f of x, this equation we'll in that case we'll talk about how to solve the problem. We'll see, like, if the f of x is 0, then we can solve the equation in a certain way. If f of x is in a function, then we have to think of different way. So this is for future, but here you can see the terms, right? You see the constants, and so these are constant coefficients, right? These are constant coefficients. These are just constant coefficients, whereas here you have your derivatives. Okay. All right. So let's see some example of linear ODE. All right. Let's just discuss some examples. We'll not solve them, but we'll just see some examples. Okay. Okay. So this is, let's change the color. Okay, so what order is this? This is a second order. All right, this is a second order because of this highest order of 2, right? This is a second order, and now since we have this constant coefficient, so this is a linear, of course this is a linear, right? Now constant coefficient equation. Now the thing is, these equations, like here, like these coefficients, they can be either constant or they can be either variable, they can be either function of x, whatnot. We'll see another example. Let's look at another example, right? X square d squared y dx square plus x dy by dx plus x square minus, let's just say, mu square y equal to 0, where x is greater than 0, mu is greater than, is a constant. Okay, so here let's discuss what's the order. You can see the highest derivative is 2, so this is the second order. Order of the highest derivative is 2, and then it's of course a linear equation and variable constant. Okay, variable coefficient. Okay, so we'll stop our discussion here, and going forward we'll talk about homogeneous and non-homogeneous equation. That's the next topic. Let's me just next topic homogeneity. Okay, versus non-homogeneous. Sorry about this. Okay, so I'm writing this so that you can also take note, and you can also, because writing helps getting things into your brain. So I hope you also write along with me and take these notes. And yeah, so next day we'll talk about, first of all, homogeneous and non-homogeneous equation. Then we'll talk about PDE, because that's another jargon that we discussed today. So we'll finish talking about these jargons, and then we'll learn about some application. All right. So why would, like, there will be some motivating examples. Okay, so I could have started with that, but I thought, like, let's just have some exposure to differential equations, and then we'll talk about, like, what could be the application, what could be the motivating examples, and then we'll start with, like, solving a differential equation. Okay, what types of solution are out there, and how can we solve one, and then we'll talk about, like, how to classify differential equation, and based on those classification, how can we solve them. All right, so I'll see you in the next class.